Hey guys, welcome to class. Today we're going to be doing lesson 6.2 as well as 6.3 because they kind of go together. We're going to look at 3 different ways that you can solve proportions. So make sure that you are open to lesson 6.2 in your notes packet. It says writing and solving proportions at the top. So before we start talking about the different ways to solve proportions, we need to first define what a proportion is. So it says the definition right at the top of your notes. A proportion is an equation. That word should cue you in that there's going to be an equal sign that states that 2 ratios are equivalent. Now, we spent the last week talking about ratios. We talked about how a ratio is the comparison of one thing to another using division. So now a proportion is when we have 2 ratios that are equal to each other. You can see an example of a proportion right here. 2/3 equals 8/12. That is a proportion. Sometimes we are given proportions where we are missing one of the numbers and therefore need to solve to figure out what it is. The other thing is we use proportions quite often to solve real life problems, and so we'll look at those closer to the end of this lesson as well as tomorrow on Wednesday. So the first method is called equivalent ratios, and this method is probably the easiest method. The problem with it is that it doesn't work for every proportion. But when it does work, it really is not too difficult. So the way this works is we're going to ask the question here. So we have 3/5 equals x over 20, and our goal is to figure out what x is in order to make this a proportion. So we're going to ask, as we look at the denominators, what do we need to multiply 5 by to get to 20? And the answer is 4. And then we know that whatever we do to the bottom, we have to do to the top. And so we're going to multiply the top by 4. 3 times 4 equals 12, and therefore x equals 12 is your answer. You have found what x is. And what this means is that 3/5, this ratio, equals 12 over 20. And this here that we've just written now is a proportion. Let's try this method a couple more times. All right, so in example 1, we're going to ask, as we look at the denominators, 7 times what is 21? And the answer is that we need to multiply by 3, and therefore we need to do the same thing to the top. And so x equals 6. As you can see, when this method works, it's pretty quick and easy. Again, the problem is you're going to see in just a few moments that it does not work for every single problem. There's not much work to show, but you do need to show what you are multiplying or dividing the top and bottom by, just like I've been doing. Let's go on to number 2. 8 times 4 is 32, and therefore we need to multiply the top by 4 as well. 3 times 4 is 12, and therefore x equals 12. You will always write your answer in the form x equals the number, just like when we were solving equations before. Let's try number 3. On this one, there's actually a couple options of how we could solve this. One option is we can say, moving from the right to the left, that 10 divided by 5 is 2. And therefore, since 20 divided by 5 is 4, x equals 4. That's one way. Another option would be you could say that 2 times 5 is 10, and therefore ask the question what times 5 would be 20 and figure out that it's 4 that way. So you can do it either way. Why don't you take just a minute and try to solve number 4? Hopefully you figured out that x equals 24 because 12 times 4 is 48. Therefore, we need to multiply the top number by 4. So 6 times 4 equals 24. So this method is called equivalent ratios. Again, when it works, I think it is the easiest method for you to use. But because it doesn't work every time, we need other methods as well. So let's move on to method 2. All right, we're not going to spend that much time on method 2 because quite honestly, I think most of you are going to choose to use method 1 and method 3 the majority of the time. But I just want to make you aware of this method. And this method is called using algebra. And basically, we are going to solve this the way we would an equation because it is an equation. And so as we look at this first example, x over 15 equals 2 over 5. If our goal is to get x by itself, we can ask the question, what operation is happening between the x and the 15? And the answer is division. And so we undo division with multiplication. Therefore, here we're going to multiply this side by 15 to get rid of the 15, or if it helps you to think about that as 15 over 1. Whatever you do to one side, you have to do to the other. Over here, the 15s cancel and give me x. On the other side, I have 15 times 2 is 30. 1 times 5 is 5. And then 30 divided by 5 is 6. So x equals 6 is the answer. You could do a check step here and plug in 6 and then simplify 6 over 15 to 2/5 and see that you get the same thing. If you use this method, I would not require you to do a check step. You could just show the work of solving it. All right, let's try this method 2 using algebra again. I'm going to rewrite my problem down here just so I have a little bit more space on the sides. And if my goal is to get x by itself, I need to ask how I'm going to get rid of the 25 to get it alone. What operation's happening between the x and the 25? It's division. We undo division with multiplication, so I'm going to multiply each side here by 25 over 1. The 25s over here cancel and leave me with x. Over here, you could cross simplify or you could multiply across. You'd get 50 over 5. 50 divided by 5 is x equals 10. So x equals 10 is your final answer there. We're going to stop there with this method. Again, you are welcome to use this. I just think that the majority of the time you are going to choose to use either method 1 or method 3. So I want to spend the majority of our time there. So go ahead and go to the next page where it starts to talk about cross products. All right, the third method is called using cross products. But before we can start using cross products, we actually need to understand what a cross product is. So you'll see the definition right here at the top. Every pair of ratios has two cross products. A cross product of two ratios is the product of the numerator of one and the denominator of the other. So they've given you a couple examples here. If these are two ratios, the cross products would be 3 times 10, which in this case is 30, and 5 times 6, which is also 30. In the second set of ratios, the cross products would be 2 times 11, which is 22, and then 3 times 6, which is 18. Now you'll notice that in one of these examples the cross products are equivalent and in the other one they're not. And that leads us to the cross products property, which says that in a proportion the cross products are equal. So what that would mean as we look back at these examples that we had just taken a look at the top of this page is that the ratios 3/5 and 6/10 are equal and therefore form a proportion because their cross products were equal. In the second example here, these are two ratios, however, they are not equal to each other and therefore not a proportion. Again, they're two different ratios, they are just not equal because their cross products are not equal. Now, this cross product property is going to help us tremendously because if we know that in a proportion, the cross products have to be equal, that's going to help us find the missing number. Now, I'm going to ask you to make a slight jump in your notes packet. Right now, as you look at this the bottom of this page, you see a word problem about mowing lawns. We are going to temporarily skip that problem and go to the next page, and then we will come back to this problem in just a few minutes. The first couple problems ask us to tell whether the ratios form a proportion. And so all we're going to do to test that is to determine if the cross products are equal. So in the first problem, 9 and 65 are the cross products and 15 and 39. So we're going to ask the question, does 9 times 65 equal, we're asking, does it equal 15 times 39? Now this is where you are welcome to get out your calculator as long as you're showing your work. So 9 times 65 is 585. 15 times 39 is also 585. And therefore, because the cross products are equal, we can say this is a proportion. Now let's go on to number 2. In this problem, 12 times 28 is one of the cross products, and we're going to ask, does that equal 6 times 45, which is the other set of cross products? Again, feel free to use your calculator as long as you show your work. 12 times 28 is 336. 6 times 45 is 270. Those, therefore, are not equal to each other, and so this is not a proportion. Now, at this point, all we've done so far is identify whether two ratios are a proportion, but ultimately the reason that we want to use this property is to solve for the missing letter or the number that we don't know. And so we're going to use this cross products property as we move down to number 5. In order for these two ratios to be a proportion, we know that their cross products must be equal. Therefore, we know that 18 times t has to equal 3 times 42 in order for these two ratios to be equal. Well, now we're just going to treat this exactly like an equation, guys. 18 times t is just 18t. 3 times 42 is 126. Now, if my goal is to get t by itself, I need to get rid of the 18. And so I'm going to ask the question, what operation is happening between the 18 and the t? It's multiplication, so I undo it with division. Again, you are welcome to use your calculator, but you must show your work just like I am. 126 divided by 18 is 7. So t equals 7. Let's go on to number 6. Again, in order for these two ratios to form a proportion or to be equal, the cross products have to be equal. Therefore, I know that 10 times p has to equal 16 times 45. Well, 10 times p is just 10p. 16 times 45 is 720. What operation is happening between the 10 and the p? It's multiplication. So I undo it with division. 720 divided by 10 is 72. And so p equals 72. Now, let's take a minute and look at these two examples that we did, because I want you to notice something. Do you notice that in number 5, we could have used method 1? And maybe some of you were noticing that. We could have said that 18 divided by 6 was 3, and so therefore 42 divided by 6 means that t equals 7. And by all means, when you're doing your homework, if you want to use that method, you absolutely can. But what I want you to notice is that number 6 is the type of problem where we run into a problem, because there is not a whole number that we could multiply 10 by to get to 16. And there's not a whole number that we could divide 16 by to get to 10. And so therefore, in this problem, number 6, method 1 does not work. You can't use it, and that's why you need this other method, and method 3 works well here. I will tell you right now, when you're doing your homework, you can choose to use any method you want. It should be clear from your work what method you used. If you would like to do your homework the most efficiently, meaning the quickest while still doing it correctly, my recommendation would be that you use a mixture of method 1 when it works and method 3 when method 1 doesn't work. And that would get your homework done the quickest. If you want just one method that works every time, no matter what, and is always the one you can go to, then method 3 needs to be your method because it works every single time. All right, why don't you take just a minute and try number 7 and number 8. All right, as you finish, go ahead and check your answers with mine. You'll notice that in number 7, the cross products are 1.5 times b, and that needs to be equal to 9 times 7. 9 times 7 is 63. To get the b by itself, I need to divide each side by 1.5, which gives me that b equals 42. On number 8, the cross products are 0.4 times z, or 4/10 times z, equals 18 times 6. 18 times 6 is 108. To get the z by itself, I need to divide each side by 0.4. And when I do that, I get that z equals 270. So this method is called using cross products. And you can use your calculator, but you want to make sure that you show all your work. Now we're going to go back one page to the word problem that we skipped previously about mowing lawns. So turn back one page in your notes. So the whole point of being able to solve proportions is that you can use them to solve real life problems. And we use proportions to solve a lot of different types of problems, a lot of different word problems. And we're going to look at a lot of problems over the next couple weeks that we use proportions to solve. In fact, almost every lesson going forward uses proportions in some way. So today we're just going to do one word problem. In your homework, there are just a couple word problems, and then we're going to keep practicing these word problems a lot over the next couple weeks. This problem says you earn $68 mowing 4 lawns. How much would you earn if you mowed 7 lawns? Now, what's important is you need to identify what unit you're going to put on top and what unit you're going to put on the bottom. In this case, they did that for you. They said that they're going to put the money that was earned on the top of the ratios and the lawns that were mowed on the bottom. So the first rate, therefore, that I am given is that you earn $68 mowing 4 lawns. Then the next piece of information is that you don't know how much money you earn, so that's going to be X mowing 7 lawns. Now here's what I'll tell you guys. It does not matter if you put money or lawns on the top as long as you are consistent. So if you put money on the top of the first ratio, you've got to put the money on the top of the second, and lawns on the bottom, lawns on the bottom. If you had wanted to, you could write this ratio as 4 lawns over $68 equals, and then you'd have to stay consistent and put 7 lawns over X. And this proportion here would give you the exact same answer, so it does not matter at all. Now, this one I'm going to use cross products to solve. So 4 times X equals 68 times 7. 4 times X is 4X. 68 times 7 is 476. Then if I want to get X by itself, I need to divide each side by 4. And X equals 119. Now, because this is a word problem, it has to have a label. And in this problem, the answer is that if you mowed 7 lawns, you would earn $119. Don't forget that $sign. That's an important part of your answer. All right, so let's turn back to the next page, the one that we had been working on with the cross products. And I want you to look at the bottom at the summary. This little chart here summarizes the 3 methods that we've looked at. The first method was using equivalent ratios, where you multiplied or divided the top and bottom by the same number to figure out the missing number. The second method was using algebra, which is where we said because it was X divided by 36, we get rid of that division by multiplying, and whatever we do to one side, we have to do to the other to figure out the answer. And the last method was using cross products, where in this problem we'd say that the cross products were 5 and 36 and X and 12, and we solved the equation that way. You notice that in all 3 examples, when you start with the same proportion, the answer is the same. X equals 15, X equals 15, X equals 15. It does not matter what method you use, and in fact, I would recommend that you use a mixture of the methods while doing your homework. All right, so hopefully this made sense. In your homework, there's a lot of problems where you're solving for the missing letter, and also a couple word problems. Don't forget on the word problems to include a unit. I hope you guys have a great day.